First of all, a simple one, which is types of flow, steady or unsteady. Types of flow. Okay, very simple one. You know this. Okay, but still, I want to put it as a completion state because there might be some gap somewhere, and that gap I want to address. Okay, first one I want to say is what is steady and unsteady flow. Steady and unsteady flow. Steady and unsteady flow. What is the difference, students, between steady and unsteady flow? Can you tell me? The thing is, whatever the equations are, okay, whether that particular in the sense velocity, especially velocity, if it is it a function of time or not, that is has to be understood, then it is steady. If it is not, it is unsteady. For example, if I say in Lagrangian concept, see, steady and unsteady, if people say it is with respect to time, with not with respect to time, people understand it. Okay, but when we go one level higher, when we think about Lagrangian concept, okay, so in case of Lagrangian concept, how do we represent this one? S is equal to a function of S naught, and then you say x, y, z, comma t. Correct. Now this time is involved already, whether it is steady or unsteady. The time factor is already involved, is it not? Even if it is in a steady flow, time factor is involved, is it not? So how do you say whether a particular flow is Lagrangian system, whether it is steady or unsteady? You will say that by finding the velocity. What is velocity? ds by dt. If this velocity is still a function of time for a particular position, okay, if there is for one position, if the position does not change, you put x is equal to 0, y is equal to 0, and z is equal to 0 or constant, okay, you don't change the position. Okay, if v of t is changing, v of t, v is a function of t for a particular position, very important. We are not going with a particle now. Okay, we are dealing with the two different particles. Okay, because when there is a flow, what happens, that particle goes somewhere, next particle comes there. So generally it is a position what is important. So we have to understand when the Lagrangian concept is done, we have to be very sure that we have to convert it into Eulerian ways and then find out whether velocity is changing with time. If velocity at a position changes with time, then it is unsteady. If it does not change, it is steady. Eulerian, it is simple. Correct? Eulerian, anyhow, we put it as velocity. Correct? In Eulerian, what we do? Velocity, if it is a function of time, if velocity is a function of time, it is unsteady. Correct? So whether it is Eulerian or Lagrangian, one of the things what has to happen is velocity. If velocity, only velocity, keep in mind, not anything else. Don't think position is a function of time. No, we are not worried about it. Acceleration is a function of time. We are not worried about it. We are worried in steady and unsteady only with velocity. Okay, if velocity at a position, at a location, is a function of time, at a location is a function of time, then the flow is unsteady. Otherwise, steady. It's all intuitive, is it not, students? Otherwise, steady. All these things are very, very intuitive. You don't have to worry about it, is it not? Fine. Easy, students? Write this down. Next, uniform and non-uniform. Let us see that. You know this, students. I have gone further. So second one, if you wanted to write, if you want me to go back, tell me. Okay. Uniform and non-uniform flow. This is simple. This is susceptible to Lagrangian also because you are going with a particle. Okay. So in case of Lagrangian, if I consider with respect to Lagrangian, so if I'm going with a particle which is over here, and then at another point of time it moves over here. Now, if velocity remains the same in case of in both direction as well as magnitude, okay, then it is a uniform flow. Okay, and what happens? I can go with a particle here. So Lagrangian is okay. Eulerian, how do you do? Eulerian, we have to go to the next point. Okay, when you say Eulerian, okay, we have to go velocity. We have to see whether it is a function of x, y, z. That means when you go to the other location, you have to go to the other location. Okay, so it is more of Lagrangian when you go for uniform and non-uniform. Correct. So what is this uniform and non-uniform? If velocity, if velocity is or velocity is a function of space, then it is non-uniform flow. It is non-uniform flow. Okay. If velocity does not change, when moved, along the flow, very important, not the other way around. Okay, moved anywhere, not just along the flow. Okay, when uh, velocity does not change with space, that would be better. With space, then it is a uniform flow. Then it is a uniform flow. I think some student has. Then it is a uniform. Easy, students. This you knew, is it not? It is not something which you don't know, correct? No, nothing. Clear? Next one. Next is very
Sir,
important. Yeah, I'm sorry.
sir, by the term space, it means the position.
Yes, space means x, y, z. When you say x, y, z, when you say space, it is x, comma, y, comma, z, not time.
Okay, sir.
Okay. Yeah. Okay. Now let us see about translation, rate of deformation, and rotation. Okay. Next topic would be that. Okay. So let us take the topic would be translation, or can we put it as okay? Let it be translation, rate of deformation, and rotation. I'm using SOM, students. Okay. Translation, yes. Rate of deformation and rotation. So first let us take translation. Let us take translation. Now, if I take translation, what do you mean by translation of a fluid particle? Okay. If I consider this is X and this is Y. Okay. What do you mean by translation? If I have a particle, small particle, okay, which I have exaggerated too much, just like I do all my classes, is it not? Okay. So sometimes humor is required. So we are good at exaggeration, is it not, students? So this is delta y, I'll say, and this is delta x. Right? Now, when it is translating, what is happening? This moves along this lines. It moves just like that. It moves without any deformation or rotation. It moves just like that. Okay, that is called translation. There are two types of translation. One is called this delta y and delta x doesn't change. Okay, that is translation. It may move this way also. Let me tell you, it may move and go like this also. Okay, till here it was a rectilinear translation. Rectilinear translation. And when it has moved here, the position remained the same. Uh, okay. From here to here, it was curvilinear translation, but it is still translation, curvilinear translation. Very important, very simple thing, but still we forget those things. So if it is A, B, C,
Sir,
and D, huh.
sir, what is delta y delta x?
Delta y delta x is the size of that small particle. It has a size of delta x and delta y. This is delta x and this is delta y. It does not change. That's what I want to say. Okay, this is delta y and this is delta x. Correct? You got the point? It does not change in its size. Size remains the same because my drawing is very poor. I cannot draw it very proper. So you have to understand that. Okay. So delta y. Okay. Yes. So here ABCD remains ABCD. No rotation, no what do you say, deformation. It is the same ABC. So this is translation. Any doubts here, students? So the particle just moves from one position to the other. Translation means particle particle moving in space or element, or you can say, we will not say particle because particle is a very not very proper now. Okay, you can say fluid element, a very small element, but still a fluid element moving in space without deformation, without deformation or rotation about its axis, about any axis on rotation about any axis on the about any axis, rotation about any axis. Okay, the fluid element does not rotate with respect to any axis. Okay, in mechanics we have seen what is rotation, is it not, students? This is what is called the translation. Any doubts here, students? There are two things: curvilinear and rectilinear translation. Write it down neatly, students, because it may seem a small one, but still, these are things which are asked in interviews, and we generally miss it out. Just like I missed that to see uh, in the sense, the lower left corner to see the bill of materials or what is the total in the sense in my B interview. Okay, I had one company called Wipro Fluids. Okay, I cleared the written test and I was in the interview. Okay, written test as well as GD. Okay, and after that, in the interview, they asked me, gave me a big sheet of paper and asked, "What is this? Can you tell me which component is this?" I had to just read it out. On the lower right corner, there would have been a bill of materials. This would be there. Okay, so that I had to just see and I had to tell. Okay, I missed on that. Okay, so I was not selected naturally. I'm a big failure student. I failed a lot of times. Okay. Don't think me as a big success. No, I'm not. Okay, slow and steady, one by one, I'm failing and then succeeding. A lot of times I fail and then once I succeed. Okay, and the success is recorded. Failures are not recorded. Okay, so that is called. There is something called. Um, there is the name. What is called for that is bias. Okay, bias for success. What is that called? Survival bias. Okay, we only see the people who have survived. Okay, what had happened is once in your during the World War, what the people used to do is they used to check. What do you say? They saw that the Allied forces, their planes, okay, which were coming, they used to see which are the places where it is being hit by the bullets. Okay, so if this is a plane in this fashion, if you say this is a plane here, okay, where it was hit, they will see. Okay, so wherever it was hit, they made it stronger. Okay, wherever the bullets were hitting, they made it very strong. Okay, but even then, the planes which were lost did not reduce. The reason is because the planes which were coming out here, coming to the base, they were the planes which were not hit at the weak points. They were the planes which were hit at the strong points only. So the place where it was weak point was the fuselage, and that was not taken into account, and that never came to the base again. Correct. So that is called survival bias. We always see people who have survived. Had they got hit on the wrong ends, they wouldn't have survived. Okay, so what we do is we always we take things from people who have survived. Okay, who are the best one. Do not take any suggestion from the people who have survived. Take people who have not survived, but don't lose motivation because of it. Okay, because see what they have done wrong and then prepare for that. That would be much better preparation rather than going with the people who think they have done right, but you do not know whether they have done it right or wrong. Correct? So another one. Now let us take rate of deformation. Very, very important. Rate of deformation. Dayananda is there? Dayananda? No. X. One. It is important to have that fire in the belly, otherwise it becomes difficult to do anything. Correct? Okay. Now what happens? This similar way, this is delta 1, this is delta x. Okay, and now this is A, B, C, and D. Okay, now this has moved to a new position over here. Okay, it has moved to a new position over here. But when it has moved, it has also deformed. So it has dilated. It is not compressed, it is dilated. Okay, dilation means when you go from a low pressure, high pressure to low pressure area, its volume increases, is it not, students? So that is called dilation. Okay, so it has dilated like this. Okay, okay, so this is the dilation. Okay, so it has dilated. Okay, so what was A, B, C, D has become now A, B dash, C dash, D dash. Initial A, B, C, D was this A, B, C. Correct. So that's how it has moved. Okay, so how to account for that? See, this is very important, and a lot of times students don't get this. Okay, so let us, I'll draw a light line here, and let me say from here, line comes over here. What is the distance between, say, A and say A and B is delta x? What is the distance between B and B dash? Okay, let's see. Now, when we say like this, see when it has moved from A to A, or let us take this as, yeah, the motion, okay, in this distance from A to this A. Can you tell me what is this distance, students? What is this distance? Let us put like this, okay, let me put it as A dash, let me put it as B dash, C dash, and D dash, and let this be B double dash, C double dash, D double dash. Okay. Now, let us not make this difficult. Okay. You know, along x direction, the velocity is u. Correct. Along y direction, the velocity is v. Correct. So, what is the distance a dash to us? If I consider distance a dash, it can be u into delta t. Agreed, students? The distance a dash is u into delta t. Agreed? Agreed, students? Correct. Now, what would be the distance between a dash along this is x, okay, along x, very important. A dash along x would be u into delta t, and a dash along y would be equal to v into delta t. Correct. So distance in terms of perpendicular, right? So it is a into a dash would be u into delta t. A dash along y would be v into delta t. Correct. Now, what would be the distance between, say, b and b dash? B and B dash would be again U into delta T, correct, along X. But what would be B into B double dash along X? What would be that distance? That distance would be U into delta T to go from B to B dash plus how when B moves from this point until it comes here, there might be a change in the velocity, correct? Because of the change in the velocity between these points, okay, there was a change here, correct? So this can be taken as dou u by dou x. How does u change with x from a to b? Observe, from a to b, u changes with x, correct? Into delta x. Delta x would be the change here, correct? So here the Taylor series expansion becomes a very important one, and here we are taking only one Taylor series because we are taking delta x as very small. Okay, if it is higher order, we are neglecting. That has to be understood. Higher order term we are neglecting. Actually, we should have included 1 by 2 factorial into delta x square again, and all those things. Those we are neglecting. That we can neglect when delta t is very small. Okay, this we do in CFD a lot of times. Okay, where we change the order. Okay, we can change the order of terms which we take into consideration when we do the this one, say like finite difference method or finite element methods. The order is important, okay, or maybe finite volume methods, okay. So order in that means this order. This is taken as first order differentials, first order terms in the Taylor series expansion only has been taken into consideration, okay. So this would be dou u by dou x into delta x and delta t. Agreed, students? Correct. So that would be my B double dash. I hope it is clear. So it is u plus dou u by dou x into delta x into delta t. Agreed, students? Easy. Similar way, if I consider, say, d to d double dash, other things we will not worry. D to D double dash along Y if we take. X is the same, okay? Along Y if we take, then it would be D to D double dash along Y would be V into delta T, correct? Plus dou V by dou Y into delta Y into delta T. Let us take delta T outside into delta T. Any doubt, students, here? Is that clear? And here, in this case, we are taking, assuming in translation or in rate of deformation, okay, in pure deformation, we are taking, assuming, okay, u is only a function of x and v is only a function of y. Only then this pure deformation happens. When will only deformation happens? Rectilinear deformation, you can call it, okay? Only deformation, only linear deformation happens, okay? Linear deformations happens only when, okay, linear deformation occurs. Linear deformation occurs only when u is a function of x and v is a function of y. Only then linear deformation happens. If u was a function of y, then what would have happened? This v would have gone over here somewhere. There would be angular deformation. Correct? That we will take the next one. Any doubts here, students? Any doubts? Clear?
Sir,
Huh.
sir, about that u by 2x into delta x.
Yes. Okay. That is the main contention here. See, what is happening is, now when I move from here to here, with x being moved, the velocity may be different, is it not? I will put it in the next slide. Yeah, write this slide, students, because I would refer this again and again. So write this first, then I'll explain you further. How do you get dou u by 2x into delta x? I'll explain further. Finished writing, students? Please tell me, because I'm waiting.
Yes, sir.
Yes, very good. Okay. So now, what happens here is, why that changes. For example, if I have a particle here, okay, and a particle here, okay. Now these are two particles in the x direction. This is the x direction, fine. Now this particle, this will have u, whereas this particle will be more than u plus delta u, is it not? Now what is this delta u? This delta u can be how u changes, like u changes with x. There might be some way, right? Some way. We do not know how u changes with x. So whatever the way in which u changes with x, the way u changes with x, we are taking into consideration, and then we are multiplying. This is the slope, and then we are multiplying by delta x. Correct? Make sense? Make sense? Correct. So now here, if you consider, this is u, okay, at this position u, and this position u plus delta u. So if we have here, this particle is moving u plus delta u. Now if you go with the direction of x, after some time, what is the distance this u moves? Say particle 1 moves, okay, particle 2, okay, particle 1 at say t1, okay, I'll put particle 1 at 1, okay, and 2 at 1. 1 refers to time, okay. So now this has moved here. This particle 1 at time 2, and particle 2 at time 2, if I consider like this. What would be the distance between u and this 1, 1 and 1, 2? That would be the distance, or we will put it as a and b. That would be much better, because when you put all the numbers, you a, b, a, b. Okay. So when you consider a1 to a2, when it is moving, particle is moving from a to a2, what is the distance it has moved? It has moved whatever the velocity into the time it has taken. Correct. That would be the distance. This would be what? This would be A2, A1, A2. Agree? Now, what would be the distance between B1 and B2? So now if I consider B1 to B2, if you consider, whatever be the velocity, what is the velocity? U plus delta U, correct? That was the velocity here into delta T, correct? So what is delta U? Delta U was U plus dou U by dou X into delta X into delta T. Is it clear? Is it clear, students? Am I making sense? Yeah, please respond, students. Yes or no? Is it clear, students? Am I audible?
Sir, in that particle,
Huh.
A1 and B1 would have, like, they are parts of the same particles, right? Like ends of the same particle.
One, no, we are not worried about particle. Let us take it as a, I've said it is a fluid element. Okay, I have corrected it. You see that? I have corrected it, fluid element. Rather than using fluid particle, I'm not using fluid particle, I'm using fluid element. An element is made out with various particles. Okay, lot of particles makes an element. Okay, yes. Now things are clear.
Okay. So, like, A1 and B1, like, they are different particles of the same element.
Same element. It's a part of fluid continuum, but there are various particles. Make sense?
Okay. Yeah.
Hmm? So fluid is dilating. Molecules are going away. Correct? Yes. Fine. Clear? Now let us see this. Now, if I consider displacement per unit time,
Sir,
if I consider
could you look at that graph?
which graph? This
Uh,
graph?
previous. Yeah.
Yeah.
Here, for B to B double dash of X,
Hmm.
you have written dou U by dou X into delta
Hmm.
X.
Correct.
Like,
B to B dash in the x distance I'm talking. I'm not talking about y distance.
yeah. So the particle, like B1 to B, like B dash to B double dash,
Hmm.
that change is dou U by dou X, right?
It is not a particle. Particle is only one. Okay. This was at
Yeah.
the time T1. Okay. This was at B1. Okay. B time 0. Okay. It would have gone if there was no variation in velocity between A and B, it would have gone to B dash. But because there is a variation in velocity between A and B, it has moved to B double dash. That's it.
Okay, the
This B,
particle A moved, the particle A have moved to A dash and B to B double dash, right?
exactly. Had it
Yeah.
not deformed, had it only translated, it would have moved to B dash.
B dash. Okay.
Make
So
sense?
what I'm asking is, sir, the it's dou U by dou X
Hmm.
with respect to change in delta X.
Correct.
Okay.
Correct.
So, like, how is that distance proportional, like dou X and delta X? Because it is moving, like we have changed it through delta dou X into delta X.
No, no,
That
no,
is
no.
that.
I got your point. I got your point. See, what is happening is this is a slope. This is a slope. This is the distance. That's it. I hope you get the point. Dou u by dou x reminds it is a slope. That's it. Correct? Getting that?
Okay, sir.
Okay. It
Got it.
doesn't, I am not dividing delta u by delta x. It is slope. Slope into delta x. Make sense?
Yeah, sir.
Okay, good. Okay. So this way, if you go with the very, very basics, things will be better. Okay. So now, if I consider the relative displacement of point B with unit time, this is with respect to time. Okay. So this displacement per time, if I consider displacement, or we can say deformation, like rather than displacement, we can say deformation, or let it be displacement only. Okay, displacement of particle P, particle B with respect to A. That is deformation, is it not? Okay, particle B with respect to A with the time, displacement of the particle or rate of displacement of the particle B with respect to time, can be given as displacement, okay, can be given as equal to dou U by dou X into delta X, correct? Because that is the difference, correct? That would be the difference between A dash, and say if I say from A to B, it was delta X. What is A dash to B dash, or A dash to B double dash? It would be U delta T plus dou U by dou X into delta X into delta T. What is the difference? See here, A dash would be U into delta T. That cancels with B dash, correct? So these two things are moving continuously. So what would be the displacement B dash B double dash? That B dash B double dash would be equal to dou U, or yeah, B dash B double dash is equal to dou U by dou X into delta X. Agreed? Correct, students? Okay. So now, if I consider similarly, I'll have a D dash D double dash, which is the deformation, is dou V by dou X, dou V by dou Y into delta Y. Agreed? Agreed, students? Okay. Now, what is meant by strain? Sometimes we consider strain, is it not? So in solid mechanics, we consider strain in solid mechanics, or anywhere. Okay, mechanics. Okay, what is strain? Strain is delta X by X, or change in length by original length, correct? Delta L by L. But here what we are worried is, in fluid mechanics, what we are worried is about rate of strain. In fluid mechanics, we are worried about the rate of strain. What is rate of strain? It is delta L by delta T into L. Is it not? So we have this strain here, correct? Delta U by delta X. What is this delta U by delta X? That happens over a time, is it not? So if I consider delta U by delta X divided by delta T into delta X, that will give me my time, is it not? So now if I consider this is with respect to time, is it not? This is at a time, this has happened at a time delta T. So time is involved here. Observe here, U by T. U is L by T, and this delta X cancels. So what is this? This is change in length per time. So what we have to do? We have to divide this delta X, has to be removed. So we have to divide by delta X to get a strain rate per unit time. So rate of strain, okay, is given by rate of strain, or rate of linear strain, rate of linear strain is given as epsilon xx dot is dou U by dou X. Agreed? Because delta X is removed, correct? Change in length per original length. This is rate of change of length. You see this? This is the rate of change of length, correct? Now this rate of change of length divided by original length gives the rate of strain, correct? So rate of linear strain is given by epsilon xx dot and epsilon yy dot, which is given as dou V by dou Y. So rate of linear strain is epsilon xx dot and epsilon yy dot, which is given as dou U by dou X and dou V by dou Y. That is the result. Easy. This is about linear strain. Any doubts, students? Any doubts here? It is it's not that direct. People just go with you say the mathematics and they stop there. That is a mistake. Okay, mathematics is easy. You just right, but you have to understand in terms of fluid mechanics. Okay. Any doubts here, students? Till now, write it down. Tell me when you're finished writing. Then we will go with the rate of angular deformation. This is rate of linear deformation. This is linear strain. Let us take angular strain next. Okay. Tell me when you have finished it and you have understood it. Let me see how many are there. So, yes, good. Anilji, you are understanding this?
Yes, sir.
Very good. Megha?
Yes,
Megha, are
sir.
you there? Yes.
Yes, sir.
Shall we move forward? Tell me when we have to move forward. Okay. And try to preempt students. Okay. Do not feel it is tough and stop it. Okay. See that to preempt things. Okay. And practice is very important, students. Just attending the classes is good. You have to attend. If you miss the classes, then it's a problem. Okay. Because if you want only the information is available everywhere, but the discipline will not be available. So sometimes I will insist that you attend the classes. Okay. That will be there, but not too much. Okay. It will not be a pressurized one because you know better what is there. Correct. What are the challenges you face? Only you know. I will not know it. Correct? And I know everybody's life is not that easy. Correct. But there is something called that reserve power. With that reserve power, we can do anything. If suppose your life is not so good, then there's a reserve power which brings you out of the out of all the problems. Okay, there was an experiment, students. Okay, this experiment was with the mouse. Okay, always we have lot to give to this mouse and rabbits and all those people, all those we have abused them like anything. Okay, so there was an experiment with a mouse. What did he do was he took a mouse and put it in water. Okay? So when a mouse is in water, okay, the mouse is in water, the poor mouse, okay, it would take one mouse around 20 minutes to drown itself. Okay, 20 minutes it will try to come up, and after it will drown and die. Okay, that is a general case with the mouse. Okay, now in case that mouse when it was drowning, just when it was drowning, okay, it was taken out and it was kept. Just when it is about to drown, it takes that mouse and keeps it away. Okay, and the mouse is happy now. Okay, but after some time again he puts the mouse. Okay, and just when it is drowning, okay, it takes it out and keeps it outside. Okay, like this it was repeated. Okay, so first time it was taking 20 minutes, okay, for it to drown, and at the end he saw the mouse was able to swim for 4 days altogether. 4 days it swam. Okay, afterwards its physical power is not good, so it will drown after that. Okay, so what is that? Its actual physical power is not 20 minutes. Because of mental fatigue, because of frustration, it would have drowned there. Physically it had a what do you say, it had a strength to take 4 days of swimming. That is the physical strength it had. Okay, so very important to know that sometimes we get tired because we get tired mentally, not because we are physically tired. Okay, so it had a hope there that somebody would take me out. I have to stay till somebody takes me out. That was the way. So this mouse which was there has suffered a lot in its life because of this scientist. Okay, but we get some this one because of the sacrifice. It is not sacrifice, abuse. Okay, sacrifice is when person does it knowingly. Okay, when somebody is abused, like the World War II. Okay, World War II, a lot of human experiments were done. Even the Nagasaki and Hiroshima bombs were human experiments. Correct. So this is not sacrifice; it is abuse. Okay. Yes, just like Bengalis in our during Winston Churchill. Okay, that was abuse. Okay, we put the great thing about Winston Churchill. Okay, I hate him like anything. Just like Hitler is being hated. Okay, who killed Jews? Okay, Jews never share any. Will never share anything about Hitler, is it not? Will you say Hitler had said this great quote? Will they share? No. But we Indians share Winston Churchill, who was responsible for killing of so many Bengalis. Okay, and say great. Okay, around 2 million Bengalis died during the famine only in Bengal. There was other famines also which was caused by British. In Deccan in 1888, they had caused this one in the Deccan area. Okay, so these are all abusers, students. Okay, fine. Anyhow, we'll not worry about that. We went on the other side. Okay, when mouse was there, it came into mind. People are human abusers also. Okay, fine. Next one. Okay, next let us go with angular deformation. Angular deformation. Okay. So if you consider angular deformation, what will happen here is velocity is not just a function of x, okay, not just linear. So here what is happening is u is a function of x as well as y, and v is a function of x as well as y. That is the main thing. There in linear deformation, u was function of x, v was function of y, but here both. Okay. So what is happening? Initial particle position, which is there here, I'll just draw it a bit. I think my head is not coming on the way, correct? I hope so. Okay. So if I consider this, say this is delta x and delta y. Okay, this is A, B, C, and D. Okay, now this deforms. Had it gone here, it would have the same ABC. Right? It would go to the same, say A dash, B dash, C dash, D dash. Would be the translating position, correct? If it had translated, it would have moved. But there's angular deformation in addition to it. So what happens? It would go over here. This would go over here like this. Okay, and then it would move like this. Okay, so it has deformed totally. Observe here. So it has moved with this. This is what happens in actual flow. There is a lot of time there is deformation. Okay, so this has moved to A dash, B double dash, C double dash, and D double dash. Easy. So now, if I consider the distance between A and A, what is the distance between A and A dash? It is A and A dash in terms of x. We have to say which is the thing x. It would be u into delta t, correct? And what would be A dash in terms of y? It would be v into delta t. Simple. Now what would be b to b dash? It would be same as u delta t in x direction. But now the problem happens. Okay. Now the problem happens. What is meant by rate of deformation? Okay. Now if you consider rate of angular deformation, if you consider gamma, okay, in solid mechanics, okay, in solid mechanics, if you consider strain, okay, just like shear strain. What is shear strain in solid mechanics? Shear strain is nothing but d alpha, if I consider the change, okay, angle here. Okay, if I say this is going with a small deformation because we are taking a small, this one, let's say d alpha. Okay, So what is strain? It is d alpha plus d beta. If I consider this as d beta, correct? Angle. Strain is nothing but angle, is it not? So strain, if you say gamma, we represent by gamma strain, shear strain, right? So shear strain gamma is d alpha plus d beta. This is what we know, is it not? So we are adding both the strains, okay? Now, rate of shear strain, if you consider, the rate of shear strain. Rate of shear strain, we are putting gamma dot. That is nothing but d alpha by dt, okay, plus d beta by dt. Agreed, students? It is d alpha by dt and d beta by dt. Agreed? Now, let us understand each and every points from now onwards, okay? Have you written it down, students? Write it down, then next time we will go for the next slide, okay? It seems difficult, it is not, okay? It is not difficult. Because we are introducing it, it becomes difficult. And you know, I'm going at least half the speed, okay? The regular speed will be double this, okay? Because I want you to be very strong in the subject, okay? So in this speed, the whole gate coaching will take around 1,200 hours, okay? But not all the things we will go in this speed, okay? Some of them, some of the other professors will go in their speed, okay? But you can come back and ask, okay? You can always stop them. One of the ways to control the speed is to ask them questions, correct? Be interactive, okay? And I don't put any thing. I don't say the professors that please stop the, what you say, in the sense, you have to complete this particular subject in so many hours. A lot of coaching institutes do that, okay? They give a target to the professors saying that they will go with a business attitude, okay? With a business attitude, they will ask, okay? So this much hours, you can, how much hours can you complete, sir? Okay, this much hours, fine. If you can complete with that much hours, fine. This much I can give you. That dealing is done. Now, whatever increase in the number of hours which is there, that is based on the professor. That is professor is giving free of cost. Okay, but here in my part, it is not like that. I give in an hourly basis, and I will not give any restrictions. Okay, so the professor is happy to increase, but that will help you students. Okay, that has to be understood. Okay, take the best use of that. Okay, because you know my main purpose is not business. My purpose is we have to do something to the society. Business has to happen. We have to earn that thing I'm seeing, okay? But still more than that, it is our improvement. Main purpose is not to make money. The main purpose is to give good education, okay? Yes, is that clear, students? Fine, done? Please tell me, students, if you have done.
Yes, sir.
Yes.
Right. You can say no also, okay? Sir, 2 minutes, okay? You can say that, okay? Don't worry about it, okay? Now let us see again, okay? So what has happened is, it has moved like this. Take the second figure, okay? So what has happened? It has moved by an angle, correct? It has moved by an angle, okay? Two angles, different angles. This was d alpha, this was d beta, correct? Now, if I consider what is d alpha, this d alpha would be equal to limit delta t tending to 0, rate of deformation, left delta t tending to 0, tan inverse of, if I consider, okay, dou v by dou, dou v by dou x. What I'm considering? Dou v by dou x. Why I'm considering dou v by dou x? Because how much it moves with respect to x, that is causing it. Observe again, okay? So here it was u, okay? What it moves up is v, correct? So this distance, when you consider, it is dou v by dou x into delta x. Agreed? correct? So dou v by dou x into delta t, because how much time it has taken, that is also important, is it? Dou v delta x delta t. Agreed, students? Divided by. Now, what was the original length? Okay, what is d alpha? What is the length from here to here? What is the length? Okay, that matters, correct? So the length here, how much it has moved like this length, okay, would be equal to, if I consider delta x into delta t, okay, because that is the time which it has taken, okay. So this distance would be equal to, first of all, initially it would have been a delta x. Observe here, here you observe. Initially it would be delta x. What is later on? What is the size of this? This size would be delta x plus dou u by dou x into delta t. Agreed, students? That would be the size, is it not? A dash, B double dash in the x direction, correct? So that is what we have to take. This and this, is it not? So what is that if you take? It is, we can consider delta x, okay, in terms of, yeah. So if you consider that, it would be u into, yeah, if I consider this thing, okay, it would be delta x plus dou u by dou x of delta x into delta t. Agreed, students? That would be the size, correct? That would be the size on this direction. Now, when a limit delta t tending to 0, if delta t tends to 0, then what will this be? This will be nothing but, see, when delta t tends to 0, this goes almost to 0, correct? This whole thing goes to 0. And even if delta x tends to 0 and delta t is over here, this comes down to dou v by dou x. It comes down to dou v by dou x into delta t, correct? Because this dou v by dou x into dt, okay, this is what it comes down to. How does it come down? Because here, if you see, these are multiplication of two small terms. Because these are multiplication of two small terms, we can neglect this whole thing, especially when it is smaller. Okay, when delta x is small and delta t is small, what remains? Delta x. Delta x gets cancelled. And when delta t tends to 0, what happens? We can write this as dou v by dou x into dt. Okay. Similar way, if I consider d beta can be limit delta t tending to 0, limit delta t tending to 0, tan inverse of dou u by dou y, dou u by dou y into delta t divided by, we have delta y plus dou v by dou y into delta y into delta t. Correct, students? So this comes out to be dou u by dou y into dt. So what is the total shear strain rate? Shear strain rate is d alpha by dt plus d beta by dt. And we know that d alpha is this, d beta is this. And divide by delta t, divide by dt, what remains? It comes as dou v by dou x plus dou u by dou y. This was in the xy plane, very important. So gamma dot, the rate of shear strain in the xy plane, is given as dou v by dou x plus dou u by dou y. Very, very, very important, students. I hope it makes sense, students. If you reproduce this, you have to reproduce it. There's no other way. You may think that it is difficult one, but it's not. It's easier one. Okay. This is some of the basics. Okay. Initially, when it is introduced, it may be difficult. Was this done to you in your BE students? Anyone? Nitin, it was done to you? This rate of deformation?
No, sir.
No. Abhik, was it done?
No, sir.
Yeah. So that is the difference between, that is why we are not able to clear gate. Okay, a lot of people don't clear gate because these concepts are not told to you. Okay, and this is a part of gate syllabus. Okay. Yeah, actually, this is part of every university syllabus also. And sometimes these private universities who are given deemed status, okay, what they do is they try to be very popular with the students, and they will take out all the what you say difficult topics. Okay, what they want popularity with the students, not they are worried about money. That's it. Okay, so because money, it's all business. Okay, so that is one of the downside of capitalism. Okay, they are not worried about what happens to the customer. Correct. They are worried about that ethical code is not there a lot of place. It is not service based capitalism. Okay, that's the new term I'm getting, service based capitalism. Okay, it's not socialism. Socialism is a great trouble everywhere. Okay, so I'll use this service based capitalism. Okay, you earn money not for yourself, you earn money for society. That is service based capitalism. I'll write a book. I'll become next Karl Marx. Karl Marx became so famous, correct? And at that time, it was the right thing to do. Do not. There are some people who hate communists because just they see communism's bad side. Okay, they will see Pol Pot, or they might see Khmer Rouge regime. They might think about Mao, okay, Mao Zedong, okay, who has killed so many Chinese. Okay, not others. Their own people. Who kills their own people? There are people. There is Pol Pot. There is Russia's Lenin. Okay, not Lenin. The other one. Who is that? Lenin was just was very harmless. Okay, the next person, who was that? His name I forgot. Stalin. Okay, so sometimes Gorbachev asked it. Okay, Gorbachev was the person who was after last you can say last president of USSR. Okay. He sometimes asked it. How what is the difference between your policies and Stalin's policies? Somebody asked. Okay. You said you will bring out difference. Okay, he said the thing that you can ask me this question is the main change what I have got, because in Stalin's time, if you had asked this question, you would have been executed. Okay, so that is the difference. Okay, fine, done, students. We consider only Hitler and Mussolini as dictators. We neglect Stalin, Mao, and our Pol Pot. These are much bigger dictators. Okay, shall we go forward, students? Okay, next. Another point.
Sir, one minute.
Tell me. You have not finished writing, is it? Please. Sometimes you get general knowledge also. Okay, I'll try to become as unbiased as possible, students. Okay, because this will help you in IES preparation. Okay, maybe a bit on the outer periphery. We will start general studies, students. Okay, we will start general studies. IES, we will take the syllabus of IES and we will start that. Okay, it's an addition to GATE coaching. This I'll give you free of cost. Okay, because I want to go next for IES. Okay, so at that time I have to see how much I can do with general studies. Because any government jobs, they consider general studies as an important part of it. Okay. I sometimes follow this IAS coaching institutes. Okay, their YouTube channels and all those things I follow. Okay, and I see their attempt to tell. Yeah. No, it's not clear, Mister.
Why delta
I don't know who
X
is
in the
who is
denominator
talking.
with do you
No, it's not clear. It was something stopping. Yeah, please.
Sir, in the
You can give me on
denominator, why
WhatsApp.
delta X along with the do you
Why delta X is removed here? This is what you are saying.
No, sir.
Fine.
I am asking
Okay,
why
I'll listen.
delta S. Why delta x in the denominator along with the dou u term?
Why delta x? There's no delta x, there's dou x only. Now you message me, or you take a what do you say? You give me a voice message. That would be better because typing will take a lot of time. Okay, in the Apex classroom, this one, put a voice message. That would be much better. Everybody will know that your doubt also. Okay, put a voice message there. I'll play out here. Okay. Done. Okay. Divya has sent me.
Sir, why delta x along with the dou u by dou x term in the denominator?
Why delta x and dou u by dou x term in the denominator. Okay. See, what is happening is the variation here, this one would have come from here. Observe here. Okay. This was delta x. But what is this? This distance, the new one, that is delta x plus dou u by dou x into delta t, is it not? So what is it coming? This is what? What is this here? This is a dash b double dash, is it not? So we need this length. What is this length? Delta x plus dou u by dou x into delta x into delta t. Agreed? Agreed? Correct? Make sense?
Sir.
Yes, very good. So next, now what is happening here is we are talking about our rate of deformation. There is something called rotation. This is another term which we have to understand. Rotation. Okay. Now this rotation is nothing but similar way. What is rotation? Rotation is about how things rotate, is it not? See here, this is there here, this is here. Okay. About an axis. Okay. About an axis. If it rotates, this is rotation, is it not, students? This is rotation. Now, when it is rotating, you have here d alpha, and this, if I consider in terms of this is minus d beta. Correct? It is d alpha minus d beta because it is going in the other direction. And then we take the average of these two. We consider the average of these two. Okay. So if it was going like this, I'm sorry, if it was going like this, it would have been d beta. Okay. So what is the average rotation if you ask? It is d alpha plus d beta divided by 2. But here in this case, what is happening is the original one is like this. Okay. And it is coming here and it is going like this. Correct. So this would be the way it would deform. Correct. So this is the original one would be here. Okay. So this is the way it would deform. Correct. So here you have this angle as d alpha, sorry, d alpha, and this angle as d beta. So my rotation would be average of this would be my rotation. Okay. So rotation would be rotation rate. Rotation rate. We are considering about rotation rate. Always when you consider rotation in fluid mechanics, it's always rotation rate. Okay. This rotation rate with respect to z axis, very important to note, it is with respect to z
Sir, here
axis,
it is minus.
would be equal to yes, I will tell you, I'll come back to that. Okay, it's minus. Here it's minus, it's coming out like this. Here it would have been plus, correct? And then you would have taken the average of this. Okay, so this omega z, okay, which is with respect to rotation rate. Sometimes we consider this as the rotation also. Let us consider like this rotation. Okay, rotation rate z. Sometimes we interchange between rotation and vorticity. Okay, we are using omega, big omega for rotation. Okay, this rotation would be half into rotation rate, okay, d alpha by dt minus d beta by dt. Very important. Okay. And what is d alpha by dt? So omega z, the rotation rate for the same thing, would be equal to half into what is d alpha by dt? It is dou v by dou x minus dou u by dou y. This would be the rotation. Easy. Rotation is the average of the angular deformation. Rotation rate is the average of the angular rotation. I'm sorry. Rotation rate of the element is the angular rate of average of the angular rate of rotation of individual this one. So if you consider this is anti-clockwise, observe this way also we can take. This is clockwise rotation, correct? Clockwise is negative, anti-clockwise is positive, correct? That makes sense, students? Correct. So this d beta is minus because it is anti-clockwise in this case. So angle rotation, angular rotation, clockwise positive, anti-clockwise positive, clockwise negative. So this is going in the anti-clockwise direction. That is why it is negative. Makes sense? But dou u by dou x is d beta by dt taken in this fashion. So that's why minus has to be there in that. Easy, makes sense? Write this down, students. Then we will give the grand summary. Okay. Let us take the grand summary in 10 minutes next. Okay. Written down, students? Okay. Let us take a grand summary of all these things. So I'm sorry, I've come to the end of the. It will not take still. Okay. So let us take the grand summary of whatever we have done. Okay. So let us have translation. First, we had linear deformation, correct? So if I had a linear deformation, or let us summarize the rotation. Okay. So rotation, when you say, or strain rate, or angular strain rate. Okay. Angular strain. If I consider angular strain, now angular strain is in 3 direction also, correct? So there is gamma xy. This gamma xy is given as dou v by dou x plus dou u by dou y, angular strain, rate of angular strain, or rate of shear strain. Let us put it that, okay? Rate of shear strain, rate of shear strain. That would be much better. The rate of shear strain would be this. And what is rate of rotation? Rate of rotation would be, we have used this one, okay? With respect to z would be dou v by dou x minus dou u by dou y. Make sense, students? Okay. Similar way, if you consider other directions, if I consider gamma, say xy, so we will say xz. If I consider gamma xz, that would be equal to dou u by dou z plus dou w by dou x. Make sense? And what would be this? This would be omega y. That would come as sorry, rate of rotation with respect to half. I'm sorry, it is with respect to half. Half is, it has to be taken half into, we can write dou u by dou z minus dou w by dou x. Okay, I will go to the depth of this and I will tell you what does it mean actually. Okay, it's much easier than what you see here. Okay, but let us write it first. Okay, similar way, dou zy would be equal to dou zy would be equal to, we can say, dou w by dou y plus dou v by dou z. This would be my omega x. That would be equal to half into dou w by dou y minus dou v by dou z. Make sense, students? Write this down. And there is a way by which we can find it out. Okay. This actually, you see, this comes as omega, which is rotation vector, if you consider it as a vector, this vector is actually equal to half into del crossed with v vector. Make sense? Very easy to find it out. What is del? Del is nothing but equal to dou by dou xi plus dou by dou yj plus dou by dou zk. See how easy it is, correct? And what is v, students? V is nothing but ui plus vj plus wk. You see, I'm connecting vector mechanics, vector calculus with fluid mechanics, correct? So you have seen what is the importance of curl. This is curl, is it not, students? Del cross is what? This is curl of velocity, is it not? Curl of velocity vector, is it not? Very, very important. Okay, we are much better in understanding what you say, even electromagnetics. Okay, there was a great scientist. His name was Horace Lamb. His name was Horace Lamb. Okay, he's a great scientist in mathematics. In 1930s, he was on his deathbed. Okay, and some interviewer, journalist, came to him and asked, "What would be your you're almost so severely ill? Okay, what do you think? What is the next thing in science? Okay, such kind of things. What is the trend in science? Okay, or what do you think? What are the failures of science?" Like that, a journalist asked a question. Okay, for that, Horace Lamb said, "See, I think I'm on my deathbed." Actually, he was on his deathbed. Okay, "I think I'm going to die. Okay, you people believe in God. I don't." He was a person who was non-believer in God. He was a scientist. Okay, all the scientists during that time was with non-believer in God. Rightly so. Okay, I'm not saying you should believe in God. No, you have to believe in truth. Correct. So he was an atheist to the true sense. Okay, so he said, "I don't believe in God, but I am dying, and in case what you say comes out to be truth, and there is God there, okay, then I'll ask him two questions. First question is why electromagnetics? Second question would be why turbulence? First one, why electromagnetics? And next one is why turbulence in fluid mechanics? Because that is the one of the major problem in mathematics. Okay, so why electromagnetics? Why turbulence? And I'm sure that God will have answer for the first one. Horace Lamb said they will have answer for the first question, that is why electromagnetics. That is, electromagnetics, only God will have the answer. And turbulence, even God will not have the answer for that. Okay, that's how difficult it is. Okay, so scientists used to make a lot of fun of all the belief systems. Okay, and that is nice to come out of the, what you say, the religious wars we are having a lot of times, is it not? We are seeing religious war for more than 2000 years, is it not, students? So one of the way to come out is ask questions. Ask questions. Whenever you ask questions, things will be very clear. Don't allow for somebody to go away without answering. Okay. And believe in truth. We have that particular type of, you say, character where you accept the truth. Okay. Yes. Is it clear, students? Have you written this down? Next, one more point I have to tell. That's it. Then it's done. So what we have done today, linear strain, okay, angular strain. What was linear strain, students? Linear strain was simple. What was it? If I could put linear strain, EXX. What was EXX? Dou U by dou X. What is EYY? It would be dou V by dou Y. What is EZZ? Strain rate. I am very sorry, students. It is a strain rate. Put a dot everywhere. Okay. This strain rate would be dou W by dou Z. Now you see this comes out to be stress tensor, students. Just like we have stress tensor, we have strain tensor. This actually comes out to be strain tensor. Okay. So when you say gamma xy is this, what is yx? It is the other way around. Dou U by dou Y and dou V by dou X. So you get a 9-element strain tensor here. Somebody, if somebody asks you what is a stress is a tensor or a scalar or a vector. Say them, it is neither a scalar nor a vector, it's a tensor. Correct? So such kind of things. Make sense? Okay, tell me when you're finished. There is one more thing which I have to tell you, which will take another 2 or 3 minutes. This I will put it public, okay? Because there are a lot of ideas which I've told here, which I feel it's better if they talk. Okay? Kindly share whatever is in the public domain, that YouTube videos in the public domain with your friends, students, okay? So help me out in getting more students, okay? Just share them, okay? Share in your, what do you say, in your students group, okay? This particular one, I'm going to make it public. Share it, okay? Might be you can put it in your Facebook, okay? Or any other social media, you can put it, okay? Give me that support, okay? So that's very much needed now. Otherwise, I cannot grow, okay? And there is LinkedIn and Facebook. This one, students, what do you say? My Apex Academy's pages are there. Please like those pages also. Okay, that will help me a lot. Okay. Done?
Yes, sir.
Yes, very good. Okay. Next, let us see one of the very important thing called vorticity. Vorticity. What is vorticity? Vorticity is nothing but curl of velocity. What is vorticity? Vorticity, I'm putting it as omega. Okay. Vorticity is curl of velocity. That's it. It represents rotation. Okay. It represents rotation with respect to this one. And always vorticity is equal to 2 times rotation. That's it. Vorticity vector. It's always a vector. Vorticity vector is 2 times rotation. So what is vorticity? Vorticity is nothing but del cross with V. What is del cross with V? It is I, J, K, and then you have here dou by dou X, dou by dou Y, dou by dou Z, and then on the other side here you have U, V, W. That is curl of velocity. So this you can make this one, so you can have it like this. It is dou V by, sorry, dou W by dou Y minus dou V by dou Z I, correct? I minus, observe this minus here, minus we have here dou W by dou X minus dou U by dou Z. Okay, that's why here you see I have made a different thing in the J. This one, this U had come here also. Observe, U comes first, W comes later. Okay, but here because this minus is not taken inside. Okay, so if I take minus inside, this would become plus. Okay, sorry, this would become plus and this would become minus. It would interchange its position. Okay, plus we have dou V by dou X minus dou U by dou Y would be K. So what is this? This is nothing but omega Xi plus omega Yj plus omega Z. Easy, students? Make sense? So you can say omega X is this, omega Y is dou U by dou X. If I want to put it like this, let me put it. Omega X is equal to dou W by dou Y minus dou V by dou Z. Omega Y would be equal to dou U by dou X minus dou U by dou Z, correct? Dou U by dou Z minus dou W by dou X and omega z would be equal to dou v by dou x minus dou u by dou y. Is it clear? So remember this. A lot of times in GATE, this question has appeared. They have given the velocity vector, they have to find out the vorticity, rotation rate. These are common. Tomorrow we will solve a number of questions on vorticity, rate of deformation, rotation, and such kind of things. Okay. So we will stop here, students, and day after tomorrow we will see vorticity in cylindrical coordinate system. Okay. Very important to remember that also. Okay. Then we will go with some more points. Most of the fluid kinematics is done, students. Okay. After this, we will go with the fluid dynamics. We will start with the Bernoulli's equation and such kind of things. Okay. So thank you, students. Thank you very much. Any doubts you can ask me. Yeah, right time stopping, is it not? I would love to be start at a right time, end at a right time. Okay, because everybody's time is important.
Sir, why did you interchange that term in the WY, this thing, sir?
Because there's a minus over here, okay? And here I'm taking plus.
Okay.
Make sense? Yes, students. Thank you very much. I hope you have written it down. Is it not? Finished writing?
Yes, sir.
Yes. So no more doubts, is it not?